Let's put dummy variables into our regressions, or as R calls them, factors. A dummy variable takes a value of 0 or 1 depending on some logical condition. Usually 0 is false and 1 is true. For instance, suppose we do an experiment, so each subject is either in the treatment group or the control group. Nobody's in both, everybody's in either one or the other. Define two dummy variables. One is a dummy variable treatment, takes the value 0 when that's false and 1 if that's true. Another dummy variable, control, takes a value of 0 for false and 1 for true. If you add those up, you'd get a set of ones. Means everybody is in either one or the other. We could do either of two regressions. We could regress y equals beta naught plus beta t treatment plus some error, or y equals beta naught plus beta c control plus some error. But if I create a regression y is beta naught plus beta t treatment plus beta c control, then beta naught is left hanging, undefined. When the dummy variable is for treatment, then that asks how the treatment subjects are different from the omitted category. When the dummy variable is for control, then that asks how the control are different from the omitted category. But if you put in dummies for both treatment and control, then that would try to estimate relative to the omitted category, but there is nobody in the omitted category. That doesn't work by logic nor by math. If you tried to run that in R, it would automatically drop one of the dummy variables. It always helps to do the math for the dummy variables. I'm not calling you a dummy, but sometimes I'll call myself a dummy for not doing the math. A regression of y equals beta naught plus beta t treatment can be rewritten in two rows to show either y is beta naught plus the error if the person's in the control group, or it's beta naught plus beta t plus error if the person's in the treatment group. The regression would estimate beta naught as the mean of the y variables among the control group and estimate beta naught plus beta t as the mean of the y variables among the treatment group. Alternatively, with a dummy for if the person's in the control group, would write in two rows as y equals beta naught plus beta c plus error for the control group, or y equals beta naught plus error for the treatment group. Either way, the dummy coefficient estimates the difference in means between the groups. The sign changes depending on which group is the omitted group, which group is represented by a dummy, but it's the same in absolute value. If you put dummies for both control and treatment into a single regression, then the mean of the control group would be estimated by beta naught plus beta c, the mean of the treatment group would be estimated by beta naught plus beta t, and I'll have two equations with three unknowns. Sad trombone music. Either you have to drop one of the dummy variables, which is what R would do, or estimate the regression without the beta naught, no intercept term. You have to leave one out of your dummy variables. That generalizes for dummy variables with multiple categories. If I had dummy variables for which of the 50 states a person lives in, I would put 49 dummy variables into the regression, but omit one of them. R calls these factors rather than dummy variables. It will give you some shortcuts, and I'm kind of ambivalent about how much you want to be using those shortcuts at the beginning. Because sometimes you slide by without really understanding what's going on. That'll be difficult later, when you want to diagnose where any problems are coming from. Eventually you want to get to the stage where the shortcuts are valuable, because you understand everything you're skipping over. But I'd suggest doing it the long way at the beginning. For instance, instead of having a set of dummy variables on education, I could create a single index value to be a factor. It's a bit simpler notation, but R interprets that as split that factor into lots of dummy variables and do a regression with all but one of those dummy variables. Just make sure R is treating it as a factor, not as some number. It's not like age or something.